In this lesson, we're going to start our look at Theme 2. Theme 2 is called A Duel in Space. It's from a description of planet Earth given by one of the Apollo astronauts on their journeys to the moon in the late 1960s and early 1970s. The views they brought back, including this photograph famously called Earthrise, changed our appreciation of Earth as a planet. What we need to do in this theme is explore a little bit more about the planet that we live on. We then need to start looking at our closest neighbour in space, the moon, and what the moon can tell us about the early Earth. And also then looking at perhaps our closest twin planet within our solar system, looking at Mars and the geology that we can interpret from the data that we're collecting from Mars. You're going to need your orange booklet for this. For this lesson, we're going to be working on pages 2 and pages 23 of your booklet. And we're going to come back at the end of this lesson to this quote about the marble. Anyway, let's go. First job, as ever when we start a new theme, is to have a look at what's in a word. So if you turn to page 23 in your orange booklet, you'll find these terms listed there. Some of these you will be familiar with, perhaps, others much less so. So what I'd like you to do is come up with a definition for each of these terms as best you can. So, press pause now and have a go at that. Remember, at this stage of what's in a word, I don't know is a perfectly acceptable answer. Let's see what you can come up with though. Okay then, let's get stuck into theme 2. The first question is normally done as a bit of research, where we look at some of the different bodies within the solar system and do a little bit of research. What we're going to do instead this time is I'm going to go through each of these planetary bodies in turn as we go out from the sun, and I'd like you to complete that table. So, we start with the sun, our solar system's star. It's huge. It has a diameter of 1.4 million kilometres. Okay, 1,400,000 kilometres. Its gravity relative to Earth, so that's how much more gravitational pull would be on the surface of the sun compared to Earth, is 28. So it's 28 times. You'd weigh 28 times more on the sun than you do on Earth. And the average surface temperature is a frankly toasty 5,505 degrees centigrade. You get some idea from the image on the right there of how big Earth is compared to the sun. The first planet out then from the sun is Mercury, a diameter of 4,880 kilometres, 57.9 million kilometres from the sun. Its gravity, though, relative to Earth, is 0.378. So it's about a third of Earth's gravity. The planet itself is a lot smaller than Earth, so therefore the gravitational pull is less. The composition of the planet is a mixture of rock and iron. The average surface temperature is quite warm. It's 167 degrees centigrade. And the atmosphere is made of a mixture of sodium and helium. Venus, then, often described as an Earth-like planet, mostly because of its size. So its diameter is 12,100 kilometres. We've now moved 108 million kilometres from the Sun. Its gravity is quite similar to Earth's, 0.907 of Earth's, so about 9/10 what you'd experience here on Earth. Composition of the planet is again rock and iron, and its surface temperature is 464 degrees centigrade. So it's hotter on Venus than it is on Mercury, which is much closer to the Sun. The reason for that is its atmosphere. The atmosphere on Venus is virtually all carbon dioxide, with a small amount of nitrogen. So an incredible greenhouse effect. Then we have come home. So third planet out, we have Earth. Diameter of 12,800 kilometres. We're now roughly 150 million kilometres from the Sun. It's actually a little bit less than that, but that's close enough. Gravity is obviously 1 because this is all comparative to Earth. Composition of the planet is rock and iron. And the average surface temperature is about 14 degrees centigrade. Handily. The temperatures that we can live at, temperatures that crucially water can exist in all three states of matter. Composition of our atmosphere then is predominantly nitrogen with a little bit of oxygen. 21% oxygen, 77% nitrogen, plus a few other bits and pieces. We then move out to Mars. Mars is much smaller than Earth, about half the size of Earth. 6,800 kilometre diameter. We're now 228 million kilometres from the Sun. Gravity is 0.377. So again, about a third of what Earth is. Composition is rock and iron again. The surface temperature now is really chilly, minus 65 degrees. Despite the fact it has such a carbon dioxide rich atmosphere, along with some argon, the greenhouse effect here isn't enough to warm the planet up. The atmosphere here is actually quite thin. We then jump out past the asteroid belt to Jupiter. Diameter is 143,000 kilometres, so that's 10 times the size of the Earth, or 12 times the size of the Earth, more accurately. We've jumped as well 778 million kilometres from the Earth. Its gravity is 2.36. So you would, on Jupiter, on the surface of Jupiter, you would weigh 2 1/3 times more than you do here on Earth. Composition of the planet now changes. We've got a mixture of rock and hydrogen and helium. These planets now are called the gas giants because of that composition of the planet. The surface temperature on average is minus 110 degrees, and its atmosphere is a mixture of hydrogen and helium. Saturn then, 121,000 kilometres across, so what's that, about 9 times the size of Earth. Distance from the Sun, 1,430,000,000 kilometres. Gravity relative to Earth is 0.916, even though Saturn is much bigger than Earth. Its gravity is a bit less because it's not made of the same things, it's not as dense. Composition of the planet is rock and hydrogen helium again. The average surface temperature is minus 140. And the composition of the atmosphere is a mixture of hydrogen and helium. Out now as far as Uranus, a diameter of 51,000 kilometres. We're now 2,870,000,000 kilometres away from the Sun. Its gravity relative to Earth is 0.889. Composition again, rock and hydrogen helium. Notice how the inner planets and the outer planets have different compositions. Surface temperature is minus 195, and the atmosphere is hydrogen, helium and methane. Neptune then takes us to as far out as we're going to be looking here. Diameter of 49,500 kilometres. Notice how all these outer planets are much bigger than the inner planets. Distance from the Sun, 4,450,000,000 kilometres. Gravity is a bit more than Earth, 1.12. And its composition then is rock and hydrogen and helium again. Surface temperature is minus 200, and again we have an atmosphere of hydrogen, helium and methane. So we see very clearly that either side of the asteroid belt, the inner planets have quite a lot in common in terms of their composition, and the outer planets then, these big gas giants, on the far side of the asteroid belt are different again. So, what I'd like us to do is think a little bit about Earth. This is supposedly one of the most reproduced photographs ever taken. It's a picture called the Blue Marble. It's taken by an Apollo astronaut, and it was the first picture taken of the whole planet. I think it was on the Apollo 8 mission, which was the first one that went around the moon. So the first time we'd gone far enough away to look back on the whole planet. Now, sometimes the Earth is described as a Goldilocks planet. What I want you to do is I want you to assess this description. How much do you agree with our planet being described as a Goldilocks planet? There is a video that explains some of these ideas that you should watch. That will be linked in the lesson description. And then I would like you to write some sentences at the bottom of page 2 saying whether you agree with this idea. Okay? Think about the Goldilocks story. Think about the nature of the porridge. Okay? Does Earth fit in with this idea? And why? What is it about our planet that may make it a Goldilocks one? Okay. As we see an image from a sunset taken in August 2016, where all the planets were in alignment and visible in the sky at the same time, or all these planets, should I say, were in alignment and could be seen. Think carefully about what we mean by a Goldilocks planet. That description perhaps links to why Earth is habitable. We need to explore that in more detail. What is it that makes Earth inhabitable? What makes Earth very, very special and possibly even unique? We'll explore it a bit more in future lessons, but for now, focus on that idea of the Goldilocks planet, and we will develop those ideas in another lesson. I'll see you then.